And this time I have got auto cycle for you, and good time to you all. Before starting auto cycle, I will have some revision for you with this piston cylinder arrangement, and what is clear volume, what is swept volume. You have to know this swept displacement, what is compression ratio, and what is clearance, what are all these. And we know this is a piston, and this is a cylinder, and this is bore. Bore means the length, the cross section. Why is the bore length given, or what is bore? Bore is the distance from the cylinder, or it is the radial distance of the cylinder. I don't mean it is the radial distance, that means double of radial distance, that is from one end to another end. Then why is bore length given? Bore length is given to find the cross section area of this piston. This piston cross section area we can find. And why is clearance volume given? Clearance volume is this the volume which is not occupied by the piston. In the cylinder we have got one cylinder, and if we have got one cylinder, some space is left in the cylinder, and it is due to some reason, so that it wouldn't hit and destroy the engine. So the clearance volume is set up in the piston, and this is clearance volume. Swept volume of swept means this the whole process which takes place in the swept region. That is from here we can see this is our clearance volume from here to here. Let me point it out. From here to here it is our clearance volume, and from here to here it is our swept volume. That is all the curves. Our work done is only from the swept volume. I hope you are not confused about this. And what is compression ratio? Compression ratio is see, we get a compression ratio, and compression ratio is the volume of this 1 to 4 or 2 to 3. This ratio of the volume at the end of the, or you can say end of the expansion stroke to the volume at the start of the expansion stroke. That is the ratio. Since the volume of state 1 and state 4 are equivalent, 2 and 3 are equal, we can also say V1 by V2 is equal to V4 by V3 is equal to our compression ratio. And if we have got this from here to here is V1, and this here to here is, let me point it out for you. From here to here we have got V1, and from here to here we have got V2. This V2 is also known as clearance volume, VC, and from here to here is our stroke volume, VS. So V1 by V2 is our RC, or compression ratio. V1 by V2, that is V1 is our VC plus PS, by our V2 is V2. What is V2? VC. I think here we have got somewhere here we have got VC plus PS by VC, and that is our compression ratio. And for this auto cycle, what we have, the auto cycle is also called SI cycle. What is SI cycle? Standard ignition cycle. And the cycles involved in this process are 1 to isentropic compression, 2 3 isochoric iteration. Isochoric means constant volume, isentropic means adiabatic reversible expansion, and isochoric heat rejection. This is isochoric volume constant, isentropic, adiabatic as well as reversible. This also adiabatic as well as reversible. Here work is done, this is work is done, and from here work is inputted and heat is added from process 2 to 3. Process 2 to 3 is heat addition, 4 to 1 is heat rejection, QR is heat rejection. And if you want to know about TS diagram, 1 to 2 and 4 to 3, 1 to 2 is isentropic, that means it is adiabatic, and 4 to 1 is isotropic. 3 to 4 is isentropic, that is means it is adiabatic. Adiabatic, the entropy are constant, that is entropy is constant, and the temperature is rising from 1 to 2 and from 2 to 3 and from 3 to 4. Is 3 to 4 is heat rejection or isentropic expansion, so temperature get down, and from 4 to 1 it is heat rejection, so it is rejected to 4 to 1. Now we have to find the efficiency. We find it as same as the Brayton cycle, and we learn about the processes. From process 1 to 2, what we have got, T2 by T1 is equal to V1 by V2 power gamma minus 1, because it is isentropic. Here we use the isentropic relation, and T2 by T1 is equal to gamma, what is the gamma, V1 by V2, V1 by V2. This is our R, or this is our compression ratio. In process 3 to 4, what is process 3 to 4? 3 to 4 is our isentropic heat. 3 to 4 is our isentropic expansion, so it is also isentropic. We use a relation for isentropic, T3 by T4 is equal to V4 by V3 power gamma minus 1. V1 by V2 is equal to gamma minus 1 is equal to R to the power of gamma minus 1, that is V1 by V2 is our compression ratio. From first, second and third we can write the efficiency as 1 minus T1 by T2, taking it common, and finally we can sum up to efficiency as 1 minus 1 upon RP. This is compression ratio to the power of gamma minus 1, and here also we have got equal temperature ratio, same as in Brayton cycle. T4 by T1 is equal to T3 by T2. This is our thermal actual efficiency, and this is we can find thermal efficiency. This is also called thermal efficiency. Here process for 1 is given. You can analyze all of these on your own. Thank you for being with us. Stay tuned till we get our engines as well. Thank you. Goodbye.